The following scenario depicts a concept for semi-autonomous contamination mitigation. The goals of this concept are to reduce the time required to conduct decontamination, reduce physical resources, increase the safety and efficiency of the process, require fewer personnel, and reduce the signature of the process. A mechanized unit conducting combat operations was contaminated by a chemical agent as it passed through a named area of interest. The unit conducted tactical decon using onboard equipment, but was only partially successful. The contaminated vehicles were directed to a planned collection point for further mitigation. Upon arrival, as the vehicles are cleaned of mud and debris, the vehicle commander remotely reports what is known about the contamination event to the CBRN decontamination team leader. The data and vehicle are then sent to Station 1 for assessment. At Station 1, a semi-autonomous system, directed by an assessment specialist, conducts a screening of the vehicle leveraging the information provided by the decontamination team leader. Contamination is mapped on the vehicle, which is then handed off to the navigation software that controls Station 2. Using the data generated at Station 1, as well as LiDAR and shortwave infrared sensors, a semi-autonomous mitigation system conducts decontamination with decon slurry spray, targeting only the contaminated areas of the vehicle. The semi-autonomous system can operate independent of human interaction or be overridden by the mitigation specialist observing the process. Once decon has been completed, the vehicle proceeds to Station 3. At Station 3, the vehicle is thoroughly scanned for contamination by a semi-autonomous system. The vehicle will be tagged as mission capable, green, mission capable with limitations, amber, or non-mission capable, red. Green and amber vehicles are returned to service, red vehicles are returned to Station 2 for remediation or consolidated for evacuation. As illustrated in this concept, semi-autonomous contamination mitigation enables a more tailorable approach by leveraging technology to minimize the operational trade-offs and maximize technical potential. This process reduces time, requires less physical resources, is safer and more efficient, requires fewer personnel, and presents a less distinctive signature for enemy target planners.